All right, a quick video about multiplying matrices. First of all, why would we want to multiply matrices? So let's imagine this. I have ordered 6 toy cars and 7 toy trucks to sell in my little shop. Each toy car takes 4 wheels, 2 seats, and 1 gas tank. Each toy truck takes 6 wheels, 1 seat, and 3 gas tanks. So the question is, how many of each part does the manufacturer need to order and bill me for? Well, we can easily figure out that the wheels will be 6 times 4 plus 7 times 6 for a total of 24 and 42, which is a total of 66 wheels. Seats, well, again, very easily figure out that 6 times 2 for the cars plus 7 times 1 for the trucks is 12 plus 7, which is 19 seats. And gas tanks, we see 6 times 1 for the cars plus 7 times 3 for the trucks, giving us 6 plus 21, which is 27 gas tanks. So that's not a particularly difficult calculation. Let's look at matrices. Let's create, and the reason I'm going to show you the matrices first is because we're then going to realize what happens if it's a much more complicated situation. I, Mr. Armerding, am ordering cars and trucks. So we're going to put this into a 1x2 matrix. And I'm assuming that you know about matrices and how to set them up and how to label them. And what I'm doing here is just talking about how to multiply these together and why, to clear up some confusion. And what we've got here is that cars and trucks need wheels, seats, and gas tanks. And we've got a 2x3 matrix. And so thinking back on what we know about matrices, since this is just a quick review, we see that we can multiply these together because the coordinates, the inner dimensions match. And we see, and let me switch colors here very quickly, that our resulting matrix is going to be a 1x3. So I'm going to go over here and I'm going to write that Armerding is going to need an order of wheels, seats, and gas tanks because the 1x3 is where we're going to get the dimension, or the labels of our resulting matrix. So going back, what do we know? Cars take 4 wheels, 2 seats, 1 gas tank. Trucks take 6 wheels, 1 seat, 3 gas tanks. And we can see the pattern in the multiplication already if we come up here and we say, well, we did 6 times 4, 6 times 4, plus 7 times 6, 7 times 6, row times column. So our matrix multiplication is take that row and multiply it by this column. And that will give us the wheels. 6 times 4 plus 7 times 6, row times column. And this gives us the first row, first column. And where does this go into our resulting matrix? Well, 66 wheels. I'm going to change colors. I'm going to go to blue. And we've now got 6 cars times 2 seats plus 7 trucks times 1 seat. Coming back up here, 6 times 2 plus 7 times 1 gave us first row, second column. And we've already done the calculation, so we know that we put a 19 up here. And finally, let me go back very briefly. I'm going to circle this in red since I circled the other one in blue. Finally, I'm going to choose a new color. I'll choose yellow, which hopefully you'll be able to see. Hard to pick colors in this program, but there it is. Finding the number of gas tanks, we've got 6 cars times 1 gas tank plus 7 trucks times 3 gas tanks. This was our first row, third column. And we've already done the calculation, and we know that we put 27 in here. So when we multiply these two matrices together, we get the same result, 66, 19, and 27. It's not really any easier, except that you could put these two matrices into your calculator and multiply them together. Again, this isn't the most complicated multiplication in the world. So here's the next step, however, and I'm just going to do it into this space right here. So let's make ourselves a little box of more complicated problem. Mr. Armerding wants 6 cars and 7 trucks. Mr. Brannon, he's one of the other math teachers at our school, he wants 3 cars and 2 trucks. Mr. Guyash, he wants 8 cars and 1 truck. And Mr. Schick wants 5 cars and no trucks. What has to be ordered for this order that's going to Meridian High School? Well, we're going to copy the wheels, seats, gas tanks matrix over. And can you see how this is already becoming really, really more complicated to do by hand? Because now what we have to do is we take the first row, which is Armerding. Actually, you know what? Hang on just a second. I'm going to, what have I got here? Let's very quickly. I've got a 4x2, 4 rows, 2 columns. I've got a 2x3, which means that I am going to have as a resulting matrix a 4x3. So let's draw the matrix. And I've got Armerding, Brannon, Guyash, Schick, and I've got wheels, seats, and gas tanks. And as you can see, this is going to be a long, involved calculation. We'll start with Armerding. Well, Armerding is 6 and 7 times each of these 3 columns. Hey, wait, we've already done that. Armerding needs 66, 19, and 27. Brannon, so switching colors here. Brannon's going to be in blue. He wants 3 and 2, so 3 times 4 plus, can I squeeze this in here? 3 times 4 plus 2 times 6 for a total of 12 plus 12 is he needs 24 wheels. 3 times 2 plus 2 times 1. So this is 3 times 2 plus 2 times 1, which is 8 seats. And finally, 3 times 2 plus 1 times 3. We've got 3 times 2 plus 1 times 3. Getting a little hard to squeeze it in and read. That's 6 plus 3, which is 9 gas tanks. And now we move to the next. Guyash. 8 times 4 plus 1 times 6. I'm going to do the working it up in my head. I've got 8 times 4 is 32, plus 1 times 6 is 6. 38 wheels for his order. 8 times 2 plus 1 times 1. 16 plus 1 is 17. 8 times 1 plus 1 times 3 is 11. And I will leave the calculation of Schick and his order and how much he needs as an exercise for you. What numbers go here, here, and here. All right, hope that helped. That's it. I have to come up with a better way to end my videos instead of hemming and hawing and umming and then saying, okay, that's it. But I'll work on that.